Good morning, everyone. So yesterday we have discussed about preparations and properties. In that, particularly with respect to in properties, particularly uh, have formation of hydrogen bond, and next one is dimerization. So the dimerization occurs due to hydrogen bonding. Okay. So now today we are going to discuss about the properties, chemical properties of carboxylic acids and its derivatives. Okay. So chemical properties. So in that chemical properties, basically we discuss about the what type of chemical reaction it participates or what type of chemical reaction it undergoes. If you look at the structure of carboxylic acid, if you look at the structure of carboxylic acid, so this is a general formula of carboxylic acid. We write like this: C double bond O OH. Here, see, we can expect almost three or four type of reactions, but here he mentioned only three. But I will tell you one more reaction. So that reaction is due to, okay, see, this is alkyl part. This is what? Alkyl part. So this is alkyl part, bond CH2. Okay, so this is our functional group adjacent to carbon atom, which is adjacent to functional group, that is generally denoted as alpha carbon. Okay. Okay. So here we can expect four type of reactions. So first reaction due to cleavage of this OH bond, due to cleavage of OH bond. So that means here this hydrogen will be replaced with generally uh, what, a metal ion. So the releasing of the species which release H plus ion, those are known as acids. So it is the basic property of carboxylic acid which readily release H plus ions. Okay, so it is acid, and generally acids undergo the reactions with bases. So when it reacts with or treated with base, what happens? It is a neutralization reaction. In neutralization reaction, we can expect formation of salt along with water. Okay, so here it will react with base. So in these reactions occurs or via what, breakage of OH bond. So this is first type of reaction. Here see, you can see this. So this is the reaction involving the breakage of OH bond. The next second reactions are nucleophilic substitution reactions. In that nucleophilic substitution reactions, so in that nucleophilic substitution reactions, nucleophile, here outgoing species should be nucleophile and incoming species also be a nucleophile. So one nucleophile is replaced with another nucleophile. Such reactions are known as nucleophilic substitution reactions. Okay, so nucleophilic substitution reactions. This is carbonyl carbon. Okay, next see here, outgoing nucleophile. So this part is known as outgoing nucleophile. This part is known as what? Outgoing nucleophile. Outgoing. So which is or which will be replaced with a incoming nucleophile. Incoming nucleophile. So that means we can say these are nucleophilic substitution reactions. In that nucleophilic substitution reaction involves the breakage of this bond, carbonyl carbon and OH bond, breakage of this bond. So breakage of this bond results nucleophilic substitution reaction. This is second kind of reaction. And third kind of reactions are what? Decarboxylation. What is decarboxylation? So decarboxylation means removal of carbon dioxide. So removal of carbon dioxide. Removal of carbon dioxide. So see, when the carbon dioxide is removed, okay, I am writing here. Okay, see. So this is R C double bond OH. When carbon dioxide is removed, what happens? This R, this H will attach it to R, and thereby we can get an alkane. We can get an alkane. And extension of this reaction, we have Schmidt reaction or Hans-Dicker reaction or Arndt-Eister reaction. So in that reaction, what happens? The same thing will happen. The removal of carbon dioxide takes place, and but we may get some other derivatives. So particularly, we can prepare amines or amides, okay, etc., etc. Okay, those reactions are which type of reaction? Decarboxylation reaction. Decarboxylation means removing of this carbon dioxide. And fourth reaction, so that is substitution reactions at alkyl group. So this is alkyl group. So this is alkyl part. And which alkyl carbon? So that carbon is known as alpha carbon. On that alpha carbon we have hydrogens. How many hydrogens? We have two hydrogens. And these hydrogens will be replaced with halogens. Halogens. Okay, so we can say alpha halogenation reactions also. So here what happens, this reaction occurs due to the breakage of alpha carbon CH bond. So alpha carbon CH bond. Okay, so these are the four types of reactions what we are going to learn in this topic. Okay, so let's see one by one. So first reactions are, what are those? Due to breakage of OH bond. Due to breakage of OH bond. Due to breakage of OH bond. Okay, let's see. So these are the reactions. The reactions of carboxylic acid with metals. So generally these reactions, in this reaction what happens? The breakage of OH bond takes places. So this is our carboxylic acid species. So in that what happens? This bond will be broken when it is treated with a metal. So when a carboxylic acid is treated with a metal, particularly sodium, sodium is the highly reactive. What happens? Immediately this hydrogen, what happens again? We may need to take 2 moles of carboxylic acid and it reacts with 2 moles of sodium to give sodium carboxylate. What? Sodium carboxylate. So this is sodium carboxylate. This is sodium carboxylate along with liberation of hydrogen gas takes place. This releasing of hydrogen gas. Hydrogen gas is a colorless gas. Okay, see you can find this here. So 2 moles of acetic acid when it is treated with 2 moles of sodium, it gives sodium acetate along with the releasing of hydrogen gas. Releasing with hydrogen gas. So when this is treated with the metal. So in this reaction what happens? OH bond breakage is taken place. Okay, and when the sodium is replaced with a base, for example, if we replace the sodium with a base such as sodium hydroxide, NaOH, so at that time we can get same product, but instead of this one, here we get water. Instead of releasing of hydrogen gas, here what we get? Here we get a water, and this reaction is known as neutralization reaction. So this is acid and this one is a base. Okay, and we have sodium hydroxide is a one type of strong base, and when it is treated with a weak base like sodium bicarbonate, so in that sodium bicarbonate also we may get same products along with a liberation of colorless gas, that is what carbon dioxide. So this we use this reaction is one of identification reaction of carboxylic acid. Okay, in practicals, in the identification of functional group of organic compound or in organic qualitative analysis, so we use this reaction to identify this carboxylic functional group. Which reaction? So this one, the carboxylic acid, when it is treated with carbon sodium bicarbonate, it gives sodium salt of carboxylic acid along with water and liberate carbon dioxide. So this is again, carbon dioxide is a colorless gas and we can find effervescence in solution. So by means of that we can identify the given the functional group may be carboxylic acid. Okay, so we use this reaction as a one of identification reaction. So here see, the resultant product is what? Salt of carboxylic acid. So salt of carboxylic acid generally we can represent like this, C double bond O. So generally we represent like that, Na plus. So ionic bond is formed between these two. And this is carboxylate ion, and this carboxylate ion gets stability. How? By participating in resonance. So when it undergo resonance, it gives another resonating structure that to be, sorry, that to be equivalent resonating structure. So that to be an equivalent resonating structure. So like this, O minus, and here what? Double bond. again this minus shifts here, again this double bond shifts here, again we get same structure. So by so this is okay. So whenever this carboxylate ion undergoes resonance, it will produce equivalent resonating structure. So due to resulting equivalent resonating structure, this get enormous stability, okay, compared to corresponding carboxylic acid. So that's when carboxylic acid readily exists as carboxylate ion. Okay, whenever carboxylic acid is dissolved in water, so same thing will happen. Again, we may get carboxylate ion along with hydronium ion H3O plus, and this carboxylate ion undergo equivalent resonance, and thereby we can get a resonance hybrid. So this is known as resonance hybrid. So this resonance hybrid is more stable than carboxylic acid. Okay, so this is about the reactions of carboxylic acid due to breakage of OH bond. Okay, so let's see second type of reactions. What are those? The reaction, nucleophilic substitution reactions, those will be facilitated by cleavage of COH bond. So that means here outgoing nucleophile is our OH minus. Outgoing nucleophile is OH minus, so CRC. So in that we learn about formation of ester. So in previous class, in the previous classes, we have prepared carboxylic acid from ester, ester, acidic hydrolysis of ester, basic hydrolysis of ester. In these two hydrolysis of esters in presence of acid or base, we got carboxylic acid. Now we are running a reverse reaction. So now what we are doing, we are treating a carboxylic acid with alcohol in presence of acid, that will result a ester along with water. So if we don't maintain the acidic medium, what happens again? We may get the equilibrium, backward reaction may take place. So backward reaction may take place. So when we maintain acidic conditions, then what happens? We can expect a forward reaction more than backward reaction. Okay, so that's why generally esterification is done in presence of acid or acid catalyze. Let's see the mechanism here. See, so this is the first step, carboxylic acid. So I will show you mechanism here. So carboxylic acid, so RC double bond O, so H, and here also we have two lone pair of electrons. So that means see, we have two nucleophilic centers. One is this carbonyl oxygen and this is hydroxy oxygen. Okay. So in presence of acid, so what is the role of acid? Acid donates H plus ion. So now this H plus ion has two options. It can go or it can bind with hydroxy, this oxygen and carbonyl oxygen, hydroxy oxygen or carbonyl oxygen. But it prefers which one? So generally electrophile always prefers to combine with more nucleophilic center. Here we have two oxygen atoms, but these oxygen atoms have differ in terms of their nucleophilicity. What is nucleophilicity? The tendency of donating of lone pair of electron. So out of these two oxygens, this oxygen readily donates lone pair of electrons to the hydrogen atom. Why? Because here it has two pi bonds. So two bonds. One is sigma bond. Second one is pi bond. Pi bond is loosely bonded electrons. So this pi electrons so generally shifts towards this oxygen. So that's why this oxygen has more nucleophilic character over this hydrogen, this oxygen. So that's why this H plus ion attacks on this oxygen. So thereby we get this hydronium and this ion. This one. Why? Because see here what happened. So this actually the positive charge should be shown on oxygen, not on hydrogen atom. Okay, so thereby what we get like this. We get this this one R C double bond O H, and this oxygen will acquire positive charge and this OH. And now this carbon becomes more electron deficient. So compared to this one, in this case, these are the carbonyl carbon. In first case, it is less electron deficient, but in second case, it is more electron deficient. Why? Because oxygen acquired positive charge. So it readily pulls this pi electrons completely towards oxygen atom. Why? Because if you recall the resonance rules, the higher electronegative atom cannot bear positive charge. If it is so, that structure is highly unstable. So if it is unstable, what happens again? It may be go back into the previous. So that means if it is not stabilized, then what happens? It readily convert into the previous one. So that is again carboxylic acid. So that's why what we are doing here, we are providing a nucleophile. So that nucleophile, so we are providing what? A nucleophile. So here the nucleophile is what? Alcohol. So in that alcohol, we have oxygen. So again, this oxygen will donate lone pair of electrons to whom? More electron deficient center. Here, the more electron deficient center is carbonyl carbon. When it attacks, then what happens? The complete shifting of this pi bond takes place on oxygen atom. So thereby we get this structure. So thereby we get the second one, this one. So again, in this one, what happens? A new bond is formed between this oxygen and carbon. So thereby this oxygen acquires positive charge. This oxygen acquired positive charge. Again, it is unstable. So that's what happened. Again, deprotonation takes place. That means H plus will be released. H plus will be released. Now this H plus, again, it wants to attack on either this oxygen and this oxygen. So why? Because here from just now it is removed from this oxygen atom. So, but here what happens? The compared to the here we have three nucleophilic centers, 1, 2, 3. So this oxygen is acts as a more nucleophilic or more electron rich. Why? Because it is attached to the alkyl part. But when but it instead of attacking H plus ion on this oxygen, so it may happens. So then what happens again? Backward reaction takes place. But what happens here? So reside having two OH groups on same carbon. So that is known as geminal. So if any carbon on any carbon, if we have two hydroxy groups, then that carbon is known as geminal carbon. Geminal carbon. So if any carbon, if we have two functional groups, then that carbon is known as geminal. So here we have two hydroxy groups, and this is highly unstable. Why? Because these are electronegative atoms, and due to repulsions, what happens? The molecule may undergo destabilization. So that's what, to avoid that one, what happens immediately, that H plus will attack on either of one OH group. So thereby it will acquire, it will get positive charge. So next step, what happens? This step. So that's why after attacking of H plus ion, after attacking H plus ion, after attacking H plus ion here, what happens? Again, we got a hydronium ion, and then this lone pair of electrons shifts here. Then this bond completely broken. So that means what happened? The water molecule will be removed. So again, this oxygen will get the positive charge. Again, what happened? The deprotonation takes places. So the H plus ion will be removed. So thereby we get ester. So this is esterification. So esterification in presence of acid. If you don't maintain the acidic medium, what happens? The whatever ester formed, again, it may react with water to give our starting material. What are these? Carboxylic acid, and second one is alcohol. Okay. So this is about esterification. And next reaction is formation of amide or acyl halide. So ester, amides, acyl halide, acetic anhydride, all these are known as acid derivatives. All these are known as acid derivatives. So that means any acid derivative can be prepared from carboxylic acid. So ester is one of acid derivative, and second one is acyl halide. See here. So acyl halide. So I'm showing the mechanism. Okay, let's see the reaction. So this is RC double bond OH. Okay, when it's treated with chlorination agent, so here we have a number of agents which can be acted as chlorine donate and chlorinating agents. But here we are using SOCl2. So SOCl2 is known as thionyl chloride. So instead of thionyl chloride, we can also use PCl3 and PCl5. But the chlorination by using these two is somewhat difficult. Why? Because the byproducts, whatever formed in this reaction with these reagents, it is difficult to remove those. But whereas when we use this one as a chlorinating agent, we can get a byproducts. This is acid chloride along with sulfur dioxide. Sulfur dioxide is a gas; it is readily removed. And the second one is HCl. So that can be removed by heating. So another product is HCl. so it can also be removed by you by heating. Okay, so that's why we are using sulfonyl chloride as a chlorinating agent. So here see, this is the mechanism. So first step what happens, so this is carbonyl carbon. So I will show you mechanism. 1 minute, let me resolve these things. Okay, so this is R C double bond O OH. Okay, oxygen has 2 lone pair of electrons and plus SOCl2. So this is sulfonyl chloride, and this sulfur has vacant d orbital. So here this sulfonyl chloride sulfur has a vacant d orbital, so that's why it can act as a electrophilic center. It can act as a electrophilic center. Now here see, we have lone pair of electrons. So again the same thing. This carbonyl oxygen is more nucleophilic than this hydroxy oxygen, but due to so whenever it is attacks here, what happens? Due to bulky size of this one, the attacking cannot be feasible. So that's why this lone pair of electrons, these lone pair of electrons readily attacks on sulfur. So thereby what happens? We may have this structure R C double bond O, it will get positive charge. This is H, and here S double bond O, Cl and Cl, and it will again acquires negative charge. It will acquires negative charge. So again, so the releasing of what happens? H plus ion taken place, and here releasing of Cl minus take place. Why? Because it is more nucleophilic, it is more electron rich, it cannot bear the electron. So chlorine is a higher electronegative element, so it can easily taken up one electrons. Okay, so thereby what we get, releasing of HCl takes place. So in first step what happens? Releasing of HCl. This is minus HCl. How? Like this. Okay, so next I will show next step. Okay, after releasing of HCl, then small rearrangement takes places. Next here, see the structure R. So this is C double bond O, and here this is what? Oxygen, and this is sulfur. Again, this sulfur is bonded to the oxygen. Again, this chlorine. So it has 3 lone pair of electrons, and this when one of the lone pair of electron is donated to electron deficient carbon, so that facilitates the shifting of this bond. So that means here what happens, this bond is completely shifted, and this bond is completely shifted. So thereby what we get RC double bond O. Now this bond is completely cleaved, and now a new bond is formed between chlorine and carbon. So along with what happens, so this is the previous one, and now this single bond becomes as double bond. So that means this species will be eliminated as sulfur dioxide. So by means of this we can prepare acid halides. Okay, next one is conversion of carboxylic acid into amides. Again, how we can do? So same thing. So R C double bond O OH, and this is ammonia, and it has lone pair of electron. So one of lone pair of electron attacks here. So then what happens? Shifting of bond takes place. R O minus, and here this is OH, and this is what? NH3, and it will acquire positive charge. To overcome that positive charge, what happened again? So releasing of proton takes place. So due to that, what we get? R C O R S. Okay, I can show that one as O minus, and this is N. Again, it retain its 2 lone pair of electrons, and this is OH. Again, it will donate one of the lone pair of electron. So thereby, what happens? And that facilitates the releasing of OH. So due to that, we get R C. So this is O minus, and here double bond. Again it will get positive charge H H. So again this bond shifts here, this bond shifts here. Sorry, not like that, not like that. Sorry. So now this time what happens? Again that lone pair of electron are negative charge shifts here. So this bond shifts here. So thereby we get what? R C double bond O, and this is NH2 Mi. Okay. So this is the mechanism formation of amide. Next one is formation of acetic anhydride. So here also same type of reaction takes place. Acetic anhydride. So formation of acetic anhydride. So what is anhydride? Anhydride is nothing but a species which is on hydrolysis produce two acid molecules. So here, okay, I will show you the mechanism. Reaction with another. This is hydrogen. C double bond O R. Again, this lone pair of electrons attacks on carbonyl carbon. Sorry. This lone pair of electrons attacks on this carbonyl carbon, so that facilitates the shifting of one of pi bond to oxygen atom. So thereby we get R O minus, and already we have OH here. Next is new bond is formed between oxygen and carbon that provides positive charge on this oxygen. So like this. Next, deprotonation takes place. Deprotonation takes place. So thereby we get this one RCO minus, and here sorry, this is OH and O C double bond O R. Now what happens? Now this here minus H plus. H plus is removed, and now this bond negative charge shifts here, that facilitates the removal of OH minus. So here what we are removing OH minus. Already what we have removed H plus. So these two will combine and form water molecule. And see, and now what we get R C double bond O C double bond O R. So this is ester. And along with what we got another a byproduct, that is water. So if water is present in the reaction mixture, what happen? Again backward reaction takes place. Again we get 2 moles of carboxylic acid. So to avoid this one, what we are doing, we are using a dehydrating agent like P2O5. So this phosphorus pentoxide acts as a dehydrating agent. So that removes the water. So the whatever water formed in this reaction, that is immediately absorbed by whom? P2O5. So thereby that facilitates the forward reaction, only single direction reaction, forward reaction like this. Okay. So this is about the formation of anhydride. So up to now we have prepared 4 derivatives. First one is ester, second one is acyl halide, third one is amide, fourth one is acetic anhydride. Okay, so these are all these reactions are nothing but which type of reaction? Nucleophilic substitution type of reactions. Okay, these reactions are facilitated by cleavage of COH bond. So here outgoing nucleophile is what? OH, hydroxyl. Okay, so in next after this we have one more. We have to discuss few reactions. So before going to decarboxylation and substitution reactions, that is alkyl part reactions, we have reduction reactions, reduction of carboxylic acid. We will discuss in next class. Okay, so thank you.